Okay, we are recording. So welcome to the study hall for November 15th. Again, the main topic for today is this, quant, problems involving sums. And then if there is further time that remains, once we cover that topic, additional sentence structure problems and sentence correction. And we got to go through the rules. You guys know how this works by now. If you're new to this, maybe you don't. If not, here's the rules. Please watch it with the submissions. Please don't submit problems that are too general or too specific. Especially not too specific. This is what most people have been doing lately, is submitting problems that are single individual problems or single individual questions. You know, how would this work in sentence correction if I had this one sentence kind of thing. I mean, guys, if you're not generalizing the question, please post it on the forum. That's why we have the forum. So, some people are taking a lot of time to type out entire questions into the study hall form. If you're doing that, then you should take that time and you should post the question on the forum instead. That's why we have those. Yeah, those exist for the explicit purpose of answering single problems, questions, type thing. Too general, people haven't been doing this as much lately, but still make sure you know that you can't. In other words, make sure you don't ask about the whole GMAT at once, or such a broad class of problems that it's not reasonable. I mean, the flip side of this, if we can cover your topic in 2 minutes, then it's not a good topic. But also, if it would take us like 12 hours to cover your topic, or 20 hours, then it's not really a good topic either. We need a topic that we can cover in an hour to an hour and a half, which is the time we have. Finally, personal issues, please don't submit them. This is a study hall that is watched by hundreds, sometimes even thousands of people. So discussing individual study plans here wouldn't really be appropriate. Instead, topics of intermediate depth. Another way of thinking about this, we'll go ahead and write this on the board just so it's more clear. Another way of thinking about what intermediate depth means is problems or topics that can last an hour to an hour and a half. Probably the best way to think about it. So, because that would explain why things that are too general and things that are too specific are not what we want. So before you submit a topic, please ask yourself, how long would it take to cover this in the study hall? If the answer is 3 minutes, please post it on the forum. If the answer is like 20 hours, then please reduce the topic to something more specific before you post it. And then finally, we need sources. You can't just throw random problems into the form and submit them, because we need to know where the problems come from. The reason is that there are a lot of companies, including GMAC itself, but also other prep companies, that don't love when their problems are distributed for free. And so we want to make sure that we're not complicit in that sort of thing. So whenever you post a problem, including one of ours, I mean, we have about 4,000 problems in our database, so we certainly don't know them all by heart. So even if it's a Manhattan GMAT problem, please still tell us exactly what the source of the problem is. So, you know, illustrations, someone took all this time to write this problem. If you're going to do this, guys, please post it on the forum. This is like a 2 or 3 or 4 minute question. This is not a study hall topic. So, official guide problems, we can't use them. Personal issues and too general, we can't use those either. So, please read the guidelines that are there when you start the process of submitting. Okay, also, please check the archives. This study hall has had, I think, more than 75 sessions at this point. There have been a lot of them. So it's been running pretty much every other week now for about 2 years. So maybe even 3 years. Anyway, it's been happening for a while. So the point is that there are a lot of previous sessions, and there are a lot of sessions that may already cover things that you had in mind to cover. So you should always check the archives first and see whether the topic that you want to cover is already in the archive. It could well be there. And if it is, please watch it first and see whether it's covered. If you watch a previous session and there's some angle on the topic that you want to see that's not there, then please tell us that. Please say specifically like which part of the topic, what aspect of it that you were looking to see that was not there. So those are the rules. Any questions about the rules? If not, then please go ahead and give me a smiley face if you understand that. Let me just make sure you guys understand where the smiley face is. It doesn't mean a smiley face in the chat box. Okay, a lot of you seem to know where that is, but just to make sure everybody's on the same page here, underneath your name, when we say give me a smiley face, underneath your name you'll notice these emotion icons here. So like Laura, that means like not in the text box, that means in that area underneath your name. Go ahead and select the smiley face and throw it out there. Because those we can all see at once. If you put them in the text box, then you'd have like 30 people trying to dump text in the text box at the same time. It gets hard to see. So, okay, so that's how that works. If you understand the rules, give me a smiley face, and then we'll move on to problems, but not sums in quant. Okay, so the problems in here, I'm going to go ahead and change your options to be multiple choice. So you should now see multiple choice options. Looks like someone is accidentally turned on the camera, so let's not do that. Okay. All right, multiple choice options. You should have them. Here's where you find those. Right there. Underneath your name, you should now see options A through E. When you select a multiple choice option, other people will not see what you pick, but this is how you respond to multiple choice questions. Again, please don't respond in the chat box. The chat box is very small, is basically the problem. And it doesn't really work if there are 30, 40 people trying to chat in the chat box at the same time. So we have these polling tools. Please use them. These are A through E choices. And it's the deal. All right. All of the questions are from GMAT Prep. It's a free software published by GMAC. Those are free. We are allowed to distribute those because it's a free product. We can't use official guide problems because it's not a free product. So be aware of the difference when you submit problems, please. Okay, let's go ahead and get started on this. Here is the first problem. There's a timer for you. Please remember when you give multiple choice answers, please give the answers that are located there underneath your name. And I'll give you a timer, and then we'll get going. Okay, ladies and gentlemen, please pick something. There are still a lot of people who don't have answers here. There's an Anne, Anna, Blake, Brett, Henrique, Jason, Kathy, Leo, Magda. There's a bunch of you guys, Ulysses. Please pick an answer to the problem. Remember, this is the GMAT. The thing to remember here is that on the GMAT, you have to pick an answer to every problem. So just to make sure we're all on the same page there, if any of you are relatively new to this exam, you got to know how this thing works. And a big part of how this thing works is that on the test, you actually have to answer every single problem in order. So if you're new to this, just make sure you know, because that's a big, big thing. You can't really ever do this whole thing of, oh, I don't know, I'm just going to skip this one and move on. There's no such thing. So you can't skip problems. You can't leave problems blank. You can't return to them later. I mean, these are things that you need to make sure that you enforce on yourself when you practice, because these are not habits that you can build in like a day. So big thing. Also, some of you are changing your responses now after all this time. You want to make sure you don't do that either, because you do need to get an answer within a reasonable amount of time here. So here's the class responses. We got a lot of different ones. There seems to be a decent plurality in favor of B, but there's definitely not a majority for anything. So the question is, what's going on here? So here's an interesting sounding question that maybe is going to sound sort of weird. But let's talk about this statement that is right here. Here's an interesting question. You can respond to this in the chat box. Do we need this? We actually don't. It is a thing that you might possibly use, but we don't need that. And does anybody know why we don't need it? Yeah, Shri has the basic idea. And then maybe a couple other people are typing, I think. Let's see. Yeah, the point is, I think that you guys are getting at the idea here, which is that if you read the question part, I mean, it's not really a distractor. That's not really what it is. It is a thing that you can possibly use. Like, it's not a complete chunk of useless material, but it's just not something that's necessary. And let's make sure you know why that's the case. So here is the actual question part of the question. That's this part. The thing that you've got to recognize is that this is not the kind of question that needs any extra information. So it's not, you don't look at the first issue, you don't look at the first statement first and judge whether you need it. Like, you should always kind of start your reasoning from the question part and say, what do I actually need? So like in general, that's a very general observation. When you see a question, you should ask yourself, like, what information is missing, or what else do I need to solve this? That's what you should think. I mean, so let me give you a couple of other examples before we talk about this one, because most questions on this test, of course, you will actually need to have information. So, like, if you have a question, you know, that is like, if I say, how long did it take Jake to drive 64 miles at constant speed? What other information do we actually need to answer that question? You can type in the text box. What else would we need? What other information would we need to answer that question about Jake? Some people are typing. It's not this problem. In case anybody is confused, we're temporarily ignoring the problem on the board. More general idea, if you have a question that you are dealing with. First thing you should always do is say, what information is not there that I need? So, okay. Okay. My chat box was frozen. I see that a lot of you guys have entered it. Yeah, that's right. So in this situation, you have a rate times time equals distance type of thing. And if you notice, you have a distance. The distance is given. The time is what you want. So that's the only unknown, because the thing you want is supposed to be an unknown. So in this case, we need the rate, like we need the speed. So that gives you a focus for what follows. So in general, now let's talk about this. Let's talk about the problem that we actually are dealing with right now. So this is very different, as you will soon see. The question that is currently on the board is what is the sum of the even integers from 102 to 200 inclusive? I mean, you know, the even integers from 102 to 200 inclusive is a group of integers that is just a group. Like, this is not anything that depends on any sort of missing parameter. So this is already a definite set of numbers. So we don't need any extra information. Like, nothing else is unknown. We can already solve this. I mean, this is a relatively uncommon situation, but it's still a thing, and it's an essential part of problem solving, that you can't really start from the information. You have to start, your brain has to start from the question part. Like, your brain has to look at the question and say, okay, question, now what do I need to find if I want to answer it? That's how the process works here. So the deal here is that that's just a thing, and you can already answer it. So let's talk about that from that point of view. So the question is just the sum of the even integers from blah to other blah. So let's write that question again. What is the sum of the even integers from 102 to 200 inclusive? When you see sum, unless you have some other strong intuition about what you should do, does anybody know another concept that is very, very closely related to sums? Yeah, averages. Very, very, very closely related. So, in fact, so closely related that unless you have something else right away that you can do, you should just by default associate these with each other. So, like unless you have an immediate intuition to do something else, you should associate sum with average. I mean, this actually goes in both directions. Like if you have a sum, you should think about average, and if you have average, you should think about sum. So, in other words, there's two different types of things that are going on here. The first is you can find a sum you can find an average rather by taking a sum and dividing it by a number, by how many terms there are, by a count, in other words. Or you can also find the sum by taking the average and multiplying it by the count. Like, make sure you have both of these ideas at your fingertips. I mean, this is the same equation 2 times, which you can definitely see. Because if you just multiply this equation by count on both sides, then you get that one. But mentally, as far as your brain is concerned, these are not really the same equation. Like, your brain will definitely think of these as 2 different things. Because your brain thinks of this as a way to find an average, and your brain thinks of this as a way to find a sum if you already have it. So it's better to have both of these. You know, you can derive one if you have to from the other. But these are both commonplace enough that you should just kind of be able to use them. So this is what we want here, because we already have a sum. Or, pardon, we already have an average. At least we can figure one out. So let's do that. It's average times how many numbers there are. So what is the average of all the even integers from 102 to 200? That seems like kind of an intimidating task. But what is the average of the evens from 102 to 200? So the thing you got to realize here is that if you had some random set of numbers, then you would have to add them all up and divide to get an average. But these are not random numbers. These are consecutive evens, which means that the spacing between them is exactly the same the whole way. So, I mean, taking an average, basal, yeah, that's going to work. And we'll talk about why in a second. So, then again, remember there are like 40 people in here. So, I mean, the person responding may not be responding to whoever just posted. That's the problem with having so many chatters in the chat box. Like this, these are all evenly spaced forever and ever, amen. So like 102, 104, 106, 108, 110, 112, etc. They're evenly spaced. And the point with evenly spaced sets is that they are symmetrical. They're like the same forwards and backwards. Like if you flipped it around, the pattern would not look any different. And the result is that you can just average the smallest and the biggest. So if you have an evenly spaced set, you can just average the highest and lowest numbers. And that's the average of everybody. So, Azamat says in the chat box, I've got a question. Here, let's throw it on the board for just a moment. Let's put that up for the class. Does the GMAT give questions with information that we don't need to solve the problem. Does anybody have an answer to that? The answer is yes, right? Definitely. What's the evidence for that? The evidence is you're looking at one. Yeah, and so what Ali is saying right now in the chat box, that the evidence is yes, they do, and there's one of them on the screen right now. Remember, these are not problems that we made up. These are official problems from GMAT Prep, which they wrote. So yeah, the answer to this is definitely yes, and in fact, you are looking at one. So there's that. Okay. It does, Basil, although this problem has nothing to do with medians. So, but yes, it does. Okay. So yeah, evenly spaced set. If you want an average of something like that, you can just average the highest and lowest numbers. So, Sid, yeah, it would, but again, this is not a median problem, so we don't really want to chase that rabbit. The average here is, it can, if you have, yes, it can be. If you have an even number of things, then your median is between the middle two. So it doesn't have to be one of the things in the set. Okay, the average here is going to be, all you got to do is take your 102 and your 200 and average those. So you can do that, and you get that. So that is going to be 151. And then you got to figure out how many of these there are. So as far as figuring out how many there are, there's a couple of ways that you can do that. Let me just give you a couple of suggestions. I see that there's a pile in the chat box. We'll look at that in a second. One way that you can do this is to realize that there are the same number of evens from 102 to 200 as there are from 2 to 100. Because that's like the same list, but everything is just 100 less. So if you make that realization, then you know how many there are without having to count them. Because if you, like, this is the first 50 evens, which is probably pretty clear. So if you realize that, then there must be 50 evens in this list as well. There's a couple other things you can do too. I mean, if you're more of a formula person, there are those. I mean, I don't want to just throw random formulas on the board because you can't figure those out if you don't know them. But does anybody know what you can still do? Like, if you can't figure out any way to calculate how many evens there are, does anybody know what you can still do? Okay, but yeah, Peter, Basil, those are ways to calculate. I'm saying, let's say you literally do not think of any way that is mathematical to figure this out. Henrique, that's still calculating, and in fact, that won't give you the right number. I mean, Henrique, that method gives you 49, and you're supposed to get 50. As a hint, where I'm going with this is much lower tech than you might think if you think of formulas as being technology. Azima, that's still calculating stuff. Yeah, you don't have to write them. That's a little bit over the top. But Paul, that's where I'm going with this. You can just count them on your fingers and make sure that you realize that this is a thing that you can do. It really, really doesn't take that long. Count them on your fingers. Make sure you know that that is a thing, is where I'm going. Because a lot of you guys are still spitting out a whole bunch of formulas and things like that. And I mean, we have a lot of students who like just don't do stuff if there's not a formula for it. And you want to make sure that you are flexible enough that if you need to, you can just get out the shovel and start shoveling dirt. And that includes just counting stuff on your fingers. Because like sometimes you kind of have to. Like the problem is dealing with, you know, the primes from 2 to 50 or something. Then you will actually have to use probably, you know, if you have a probability thing there, you'll have to actually count those primes. So like same sort of thing, you might have to actually count them. If you're using your fingers, it really doesn't take that long. I mean, you can probably count all 50 of these in something like 15 or 20 seconds. Because you can easily count a couple of evens per second on your fingers. So however you arrive at this, Vic, we actually spent about 5 or 10 minutes talking about why you don't need the first statement. So if you were late, you can catch that on the recording. Okay, so anyway, you have 50 evens. So then you can figure out that this sum is going to be, the short version though is that it's not really necessary. I mean, you can look at what's up here, and we wrote down most of the discussion, so you can probably figure out what's going on by just looking at this. Here the sum is going to be 151 times 50, which is B, like boy. So that's one way to do it. We'll talk about another couple of things in a little bit. In case anybody is late here, here's the deal. Your study hall topic is this. This is the main topic for today. If we run out of time, then we won't do any of this till next time. But if we do the sum problems that we had and we still have time, then we'll look at a couple of sentence corrections. So that's what's happening there. Okay. All right. So any questions? There's two main ideas that we've seen so far. The first is that you actually don't need the first statement. So there's a lot of clutter on this page. Let's make sure we get the main lessons from that last page on one board. So one main lesson from the last page is you don't always have to use all of the information. And I mean, okay, let me make a couple of statements here. There's going to be a little bit of speculating that's going to happen, but a lot of this is, you know, nonetheless important. Like, on the current version of the GMAT, like the thing that they're giving right now, most problems use all of the information given. Most of them do. On the other hand, like I said, there's going to be a little bit of speculating that's going to happen here. But there's this new thing which doesn't matter terribly much right now, but it's called integrated reasoning. And I think integrated reasoning is basically predicting where this test is going to be headed in the next few years. So on the other hand, like the whole point of that IR section, though, is to give you tons and tons of information, most of which you don't need for any given problem. And I mean, notice that the point is that this is like real life. And in particular, like business. Because, I mean, the big problem with spoon-feeding all of this information is that, you know, real life doesn't do that. They don't just hand you exactly the information you need to solve problems. So that's, and I think, I mean, the reason I'm talking about IR right now is not because IR is that important. It's not terribly important. But instead, the reason I'm talking about this is that these, like, eventually, this is most likely an indicator of where the emphasis of the GMAT is headed. So in other words, I mean, I don't know if I hope that people who are studying now are not going to be taking the GMAT in like 5 years. But, you know, just in case anybody kind of drops out of the thing for a while and has like little babies or something and then goes back and decides to take the test later. The point is that this is probably where they are going. They're probably headed towards a test that requires more of you in terms of like filtering out useless information and keeping what is useful. Another lesson that we had was, so totally, that's a very general lesson about everything. And then specific lessons about sums and series of numbers. So one that we learned is that you should like see sum and average are closely related. And there's those two formulas. You know, you've got sum is average times how many. And then you also know that the average is the sum divided by how many. So there's that. And then also, when you have an evenly spaced set of numbers, the average, which is also the median for sets like that, is just the average of the biggest and smallest numbers. And then finally, lastly but not leastly, is don't be afraid to count things manually. And to do things manually in general. Like if you really can't think of another way to do something and you can just do it on your hands, then guess what? So, okay, there's that. Now let's look at two more things about this problem. Any questions about the lessons on this page? So, you know, just highlighting, you know, with boxes, the things that are most important. That, evenly spaced sets of numbers. The average is just the average of the biggest and smallest. And don't be afraid of manual calculation, including counting things on your hand. Okay, here's the problem. Let's put it onto a clean new page. If we can. I think it's not letting me copy and paste. Oh, that's horrible. Okay, here's the problem. We have to copy it, all that stuff on it. All right, the problem is now, this problem needs to take a shower now, but it's not letting me copy and paste it clean. So there's the problem, and then let's get the answer choices real quick. The answer choices are here. So let's import that. Okay, there you go. So the question is, what if you wanted to use the first statement? I mean, can you? The answer is yes, you can. If you really want to. Like, they're not giving you a completely irrelevant piece of information here. But if you really want to, then you can use the first statement. So you know that 2 plus 4 plus 6 plus 8 plus plus 98 plus 100 is 2,550. And you want 102 plus 104 plus 106 plus 108 plus plus 198 plus 200. So what you can probably see here pretty quickly is that this is 100 more than this is 100 more than that, this is 100 more, this is 100 more, this is 100 more, everything's 100 more. So you're adding, I mean, there are 50 of these, and you're adding 100 each time. So the number you want is 50 times 100 is 5,000 more than the given 2,550. So that's also B. Peter, your question that you typed, I mean, in data sufficiency, you just use whatever is in the statement. You may or may not need it, and it may or may not help, which is the crux of data sufficiency, but the difference in problem solving because you have two statements that you may or may not use. Okay, so that's one way to do this. It's 2,550 plus 5,000. If you wanted to use the first statement, you can certainly use it. They are being more helpful than usual. Like I would think they would give you the sum of like 1 through 50 first. Then you'd have to double it first, and then you'd have to do that. But whatever they give you. Okay. Finally, one more approach that you can take. One more thing. Here, the answer choices are really, really far apart. Who cares? Does anybody know why that matters? Let me know what you can do when the answer choices are really, really far apart. You can estimate. Yes, you can. Like the point is that none of these answers is really within like, you know, even 50% of the others. So you don't really need to be super exact about this. Estimate has two T's. You don't need to be super exact about it. So, oh, are we not on the screen? Okay, did you guys see this? Was this the screen that you guys were looking at? Is that what you meant by page number? You saw the wrong screen. I mean, this is not from a book. This is a problem from GMAT Prep software. So, okay. The answer choices are really, really far apart. So you can the point is that you can estimate stuff. Like these are so far apart that if you are anywhere close to the correct value, then you will be just fine. You know, you would have to be off by some colossally huge percentage to be not okay if you made an estimate here. So like if you're using the average times count, I'll leave there's only 50 numbers though, there's not 100. Okay, so if you realize that you're looking at, like you want average of 102 through 200 times number of evens from 102 to 200. I mean, let's say that you don't really know how to calculate these. Then just get an estimate. I mean, this is the average of about 100 to about 200, where you have evenly spaced numbers. So if you don't really know how to calculate that, you can still just realize that, okay, this is going to be really close to 150. Like it might not actually be 150, but it's going to be darn close. And then this is, there are, you know, it turns out there actually are exactly 50 of these, even if you didn't realize that. You're like, dude, you know, there's about 100 numbers between this range, and I'm taking half of those. So it's about half of 100, so this should be close to 50. Again, as it turns out, this is exactly 50, but that's not the point. The point is that you know it's going to be really close to that, even if it isn't. So this is going to be super close to 150. This is going to be right around 50. And the answers are ridiculously far apart, so this is more than good enough. So you know that your answer is approximately 150 times 50. So that's 7,500, approximately. So definitely good enough to get us B here. So if you have answers that are super, super close together, like they are here, then make sure that you have estimating as a possibility on the table. Any questions about that? Type them in the text box if you have questions. If not, we will look at another problem. Okay, so let's look at another problem. Let's look at this one. So again, remember multiple choice answers. Remember where you want to answer those. You want to answer those here. Let me clear out your responses. Okay, here's a timer. Have fun. Okay, only about half of you have answered the problem. So remember how the GMAT works. You can't not answer the problem. So please pick something. There's a Sid, Rame, Sam number 1, Monty, Garango. Okay. All right, so again, if you don't have an answer, you really need to pick one, but let's move on. If you are one of the 6 non-responders, here is me, but if you're one of the other 5, make sure you know that you can't not respond. All right, well, let's take a look. So what do you think is going on with this? Sum of the first 10 terms. The idea being that this is a little bit too much to calculate directly, unless you are an absolute wizard at arithmetic. So, is this a smallest and largest thing? I mean, it depends on what you mean. I'm not really sure what you mean by possibility, but this is not a problem where you can just do the average of anything with smallest and largest, because this is not an evenly spaced set. So, but let's get at this as sort of a general lesson. Like if there's too much to calculate directly, what are they trying to get you to do? Well, what they're trying to get you to do is just recognize a pattern or a trend. So that's a very general takeaway for you to get here. Like, if there are too many steps for direct calculation, then you should look for patterns or trends. And by the way, make sure that you are not too down on the ability for direct calculation. I mean, don't underestimate what you can calculate by hand. But in this case, it's probably a bit rich to try to calculate this directly, unless you are fine with denominators like 1024. So don't underestimate what you can. As we said in the last problem, I mean, there's a lot of dirt that you could shovel in a couple of minutes. But if you honestly really start doing something manually and you see that it's going to just get crazy, then you should start looking at pattern recognition instead. So, I mean, let's write out the first few terms and just see what the heck is even going on here. So, write out the first few terms. Let's take a look at that. Well, the first term is -1 squared, which is +1 times half. The next term is -1 cubed, which is -1 1/4. Then you get -1 to the 4th, which is +1/8, and then you can kind of see what the pattern is: -16 plus a 32nd minus, etc. So, and just to make sure that you know which corresponds to which, this is the number when n is 1. This is the number when n is 2. This is the number when n is 3. This is the number when n is 4, and so on. So there you go. All right, well, I mean, we want the sum, so what we should start doing is start looking at smaller sums. You know, because if we see what happens with the sums of X number of these, then we can probably get a grip on what happens with 10 of them. So if you just have these two, then that's a half minus a quarter, which is a quarter. Then if you take that and you look at the next term included as well, so the first three terms, and the first two are still a quarter. So if you have these, that's a quarter plus an 8, which is 3/8. If this seems a little bit slow, it's because changing colors a lot is sort of annoyingly not fast on Illuminator. If you want to look at the next term, then that's 3/8 minus a 16th, which is 3/6/16 minus a 16th, which would be 5/16. If you look at the next term, you're adding 1/32nd, 32th, whatever you would call that. So 10/32 plus 1/32 is 11/32. So then you want to stop and be like, okay, what is going on here? I mean, there's a definite pattern here. You know, all of these are between 1/2 and 1/4. And you aren't really going anywhere. You know, if you look at this the numbers that not only are you adding and then subtracting every time, which means that most of these things will cancel each other out most of the way. But also, I mean, you can see a progression that's not going anywhere. It's a progression that's just staying stuck around where it is. So, and I mean, you know, dealing with numbers like a 64th and a 128th and stuff like that will not get you out of that zone. So this is going to be this. It's going to be between a fourth and a half. So, I mean, the main deal here is that you can just recognize the pattern. And the clue that you want to be trying to do that is there's too much to just do manually. But that's the difference. Like if they asked you for the sum of the first 5 terms, that's not really that hard. I mean, you could just find this. This would not take you much time. So by all means, you should just add up all 5 terms. But 10 terms is getting to be a little bit much. If they asked you for like 20 or 100 terms, then of course that would be plainly ridiculous to do by hand. So then in that case, you would just want to look for a pattern. So, pattern. Any questions about that? Okay, so let's take a look at this question that people are asking here. Can we use the Jason? That method's pretty good too. In fact, that method lends itself to using. Peter, I don't really know what you mean because there's no graph in this problem, but if you're doing something involving making a graph, then if you can do that in time, then by all means, go ahead. But it seems like it might not be a very time efficient thing to do. Okay, so the lessons that you got here on this last slide, then we'll look at this geometric thing. From the last slide. So if there's honestly too much to calculate, and again, don't make that sort of decision too quickly, then look for a pattern. That's the deal there. In fact, that's pretty much the deal, aside from don't be afraid to write out a bunch of possibilities. Okay, so there's that. Let's say there's a question in the text box. Let's go ahead and address it somewhat here. So here's the question from the text box. Let's make a new page. There you go. Again, sorry, there's sort of a mess on there. But there's the problem prompt, and here are the answer choices. Okay, so, and let's go ahead and white box. Let's go ahead and kill that other thing. That's there. Okay, so Peter Guarango, says, I mean, I don't know if I'm saying that right or not, but Guarango asks, can we use these geometric series? I'm assuming it's what we would call geometric series over here in the States, but I don't want to spend too much time on this because it's not as important as the pattern recognition aspect. But yeah, you can, right? If you know them. So if you look at this series, it's plus a half, minus a quarter, plus an eighth, minus a 16th, etc. So this is a geometric series where if you don't know what that is, then either look it up on the internet or in a textbook or whatever, or honestly don't stress about it that much because it's not going to play a big role on this test. But if you do know what this is, you can use it. Each term is, the first term is 1/2, and then each consecutive term is -1/2 times the previous one. So in other words, the ratio is a constant ratio, which is 1/2, -1/2. So I don't have any idea what these formulas are, but I know they exist. So if you happen to know what the formula is for this kind of thing, then you can plug in first term is 1/2, ratio is -1/2, and then number of terms is 10. And it'll give you some horrible, horrible fraction that will indeed be between 1/4 and 1/2. So yes, the answer to this question is yes. It's not, I mean, the chance that you'll get to do this on your GMAT is very low. And the chance that you'll get to recognize patterns on your GMAT is very high. So priority-wise, this is not priority A1. But if you know how this works, then yes, you can use it. Okay, other questions, if you have them, type in the text box. If you don't, then we can do another problem. Okay, let's look at, see, 1 or 2 more. How about that one? Give you the timer with 2 minutes or so on it. Boom. Had a good time. Okay, there are a lot of non-answers right now. There's only actually 19 of you with answers out of 32. So make sure you pick something that is a something. Even if it is a totally random guess. Okay. Couple of you still with no answers. Remember, that's not a thing when you take this test. There's no abstaining from the questions. So just, I know I say that way too many times, but you can't not answer these. So if you are Rame or Sam or one of the other non-responders, Monty, yeah, pick something. All right, here's your class results. I mean, so people are kind of picking lots of different answers here. There's not much of a consensus on anything. In chat box, who's got an insight into this one? Anybody? Yeah, it's the only way to do it. It's actually the only way you can do this one. The main point of this problem, I mean, it's still a sum problem, but you're not going to get any formulas to happen here. Like sometimes you just have to shovel the dirt, is the point. I mean, sometimes there are no beautiful ways to solve these problems at all. I mean, there are some clues in this problem that that's the case. But the point is you need to have this mentality where if all else fails, you can just get the shovel out and go to work. So, because that's totally what has to happen here. is you just have to shovel the dirt. So if you look at what's going on, I mean, this is a big clue. I mean, remember that algebra has no way of doing integer problems because algebra doesn't know whether things are integers or not. So in general, you can't do this kind of thing with algebra. I mean, unless it's consecutive integers, like unless it's much more restrictive. Like if they tell you that the integers are consecutive, then okay, that's a whole different game. And that's something you can do. That's a different ballgame, and you can totally do that. But random 3 positive integers, there's literally no way to do this other than to just write out stuff and see what happens. So, oh well, I guess we just have to write cases out. So let's organize. Don't test cases. Don't test random cases. Like even when you are just shoveling a giant pile of proverbial dirt, you can still be very organized in doing so. So like let's just, I mean, it doesn't matter how you organize it as long as you organize it. So like one way to do this is to start with the biggest possible numbers. So like let's start with the biggest possible numbers. I mean, notice that which would be one of the integers is 8. Because if it's 9, you already got 81. 81 is too big. So can you get 8 plus blank, 8 squared, plus something squared, plus something else squared? Well, that would be 64 plus something is 75. And by the way, what helps is to write out a list of possibilities so you can just stare at it. So 1, 4, 9, 16, 25, 36, 49, 64. Those are the numbers that you're dealing with. So can you get 64 plus 2 of those other things to be 75? Well, this would have to be 11. So it should be pretty clear that the answer to that is a no, because you can't get an 11 out of those. I mean, the closest you can get is 4 plus 9, which is 13, but 13 is not 11. So it's not going to work. So then let's just go in the next possible order. 7 squared, so that's 49, plus something plus something. So in that case, these would have to add up to 26. And then if you just look at your list, then you can get that. You can get this. Okay. So there you go. So 49 plus 25 plus 1. So the integers are 7, 5, and 1. And there you have it. So I guess that we're looking at E. The main point of this problem is sometimes you just have to shovel the dirt. You really do. Sam, that is an approach that may not work if you're just looking at ones. Like, for instance, Sam, if you wanted that to be 77, then your approach wouldn't work because that would be 64 plus 4 plus 9, and you wouldn't find that. Like if you just said 64 plus 1, oh, that doesn't work, then you would lose that one. Because you don't have to have a 1 as one of the numbers. The point is just to be organized in some way. it doesn't have to be super high tech. Like, this is not a really complicated way to organize. Let's just start with big things. Something. I mean, there's a lot of ways to organize. So, but make sure you write stuff out too. Like, don't make yourself do a lot of things in your head. And then, yeah, different is important here too. If you don't realize they're different, you can bungle it. The three odds, or yeah, the odds and even thing that shouldn't be the first thing you do, because I mean that'll still leave you with three answers. But if you needed some sort of desperation method, or if you had like 10 seconds, then you could do it. But otherwise, that's not a good first approach. Jason, no. That was the whole point of this initial discussion of sometimes you just have to get the shovel out and shovel the dirt. Is that there's absolutely no other way to do this. That's the point. Yeah. Okay, here's what we're going to do. I'm going to throw one more problem on the board. We do have to be done in 10 minutes. So the next problem, we'll be able to do it, but then there won't be time for a ton of discussion about it. I'll just have to kind of present a pretty quick solution. But just to maximize your time here, one more problem about sums. So go ahead and try that. The data sufficiency problem. Give that a shot. Oh. There's what we want. It's better because you get the report. No, it's still better because if you deter it, Okay. Yeah, the last problem, Leo, your comment. I mean, if that's the words you wrote there are not entirely accurate because I mean 7 is not too big. 7 is actually one of the numbers, but whatever it is. Okay, so let's just discuss this really quickly. Yeah, if you're eliminating that, that kind of boils down to what we did on the board. But as long as you're organizing it, then good. As long as you're not just plugging in random possibilities in no order. Okay, so here are your answers. Again, let's go through this very quickly because we do have to get out of here in about 5 minutes. But there's a lot of B's and a lot of E's here. So the first thing you need to do here is clarify what the question is in the first place. So is each of the numbers in the list equal to 0. So what does that mean? Well, it's a yes-no question, right? So make sure you know what yes and no mean here. So a yes to this question would mean each number is 0. In other words, every number in the list is 0. No means that this is not true. In other words, you don't have to have non-zero for everything, but at least one of the numbers is not 0. So this is how yes-no question means. If you can get both of those to happen, then it's not sufficient. If you can't, if you can only get one of these to happen, so then it's sufficient. So if you can actually make both of these situations happen, then not sufficient. If you can't, in other words, if you are stuck with just one of them, then sufficient. All right, well, let's see. The product of any two numbers in the list at all. This means that if you take any two numbers from the list whatsoever, then you get 0. So statement 1, again, we got to make this sort of quick, but it's easy to get a yes here. You just make all the numbers 0. So if you want to get a yes, there's got to be at least 3 numbers in your list, too. That's the other thing. You need at least 3 numbers. That's supposed to say 3. Let me fix that. You need at least 3 numbers. Okay, to get a yes, you can just make your list have 0, 0, and 0 in it. So that satisfies the statement. So, and then if you want to get a no, what you can realize is that the product is going to be 0 if at least one of the numbers is 0. So if I make the first number like, 465.2, then the second number is 0 and the third number is also 0, then if you take any two of these, you will still get 0. Like this times that is 0, this times that is 0, and of course this times that is 0. So you can get both yes and no. All right, now what about statement 2? Statement 2, I mean, again, it's very easy to get a yes here. All you got to do is just pick a bunch of zeros. So 0, 0, 0. All right, the sum of any of those is 0. All right, now let's try to get a no. So let's pick a number that's not 0. Let's see if we can get, I don't know, like 14 in there. Well, what does the next number have to be? Because remember, you need all of the sums of pairs to be 0. So if I have a 14 in my list, then what is the next number? The next number's got to be -14, because otherwise it won't be 0. But then this is where you're in a bad position, because now you can't pick a number that will work with both of these. So, frowny face, because you have 14, this blank needs to be -14. But because there's a -14, unfortunately, it also has to be 14 at the same time. Can't be both at once. And if you think about it more generally, I mean, you can either realize that any number will do what 14 does here, or you can just call it n, where n is not 0. Then your next number has to be -n. And then you have the same, because these numbers are, if n is 0, then it's not a no. So again, the blank, unfortunately, has to be both n and minus n at the same time. And that's impossible. So it looks like you're stuck with yeses here. And what that means is that this is sufficient. So you can't get a no. That's how that works. Again, it's more of the brute force method. So your overall answer is B here. But again, the lesson here is kind of the same as the last one, which is don't be afraid to shovel the dirt. So, Natalie, you can't even get a third number. So you definitely can't have a list with 4 numbers because you can't even have 3. Like if this, remember we're talking about something that has to work all the time for any 2 chosen numbers. So if you can't even find 3 numbers that do this, then you definitely won't be able to find 4. Because the point is you would have to find 3 on your way to finding 4. So if you can't even get 3, then it's not happening. Okay, so any super quick questions, meaning, we can nail them in the next like 30 seconds or so, then fire away. Thanks for attending. It's been fun. Remember, the next study hall, I believe, is another 3 weeks, but go ahead and check the page just to be sure, the study hall page. I think someone is using the raise hand thing. We don't really use that functionality here. So if you have a question, you can just type it. Johanna, no. If you consider these 3 numbers, then the first statement is true. It's got nothing to do with digits. I'm not sure what you're getting at with digits there, but digits are not relevant. Like, I mean, you can't pick 1 digit out of a number if that's where you're trying to go with it. Well, if it's 1, 2, 0, it just doesn't work. You would just ignore that. I mean, that's a set that doesn't satisfy the statement. And remember, you're only working with sets that actually do this. So, yes, Natalie, but not the point, because you're not adding all the numbers up. You're adding any 2 numbers at a time. So, we actually don't care what happens when you add up all of the numbers. You're supposed to make a set that, like, read the condition very carefully. It's a big part of what they're testing here. Can you read these things carefully? Yeah. It's any 2 individual numbers. Okay. Rami, it's a no to the question. The question is up there. I mean, the questions that you guys are asking right now, Rami in particular, it seems like you're not fully vested yet in how data sufficiency works. Like it seems like it seems like you're still not clear on the fact that there's a question and then that there are statements. And the yes, no is the question that's up there. But the qualifying numbers that you look at in the first place are the ones that correspond to those numbered statements. So make sure that you have that straight before anything else. So there's that. Okay. All right, let's go ahead and quit. And thank you guys. And have a good holiday. Yeah, have a great Thanksgiving to you as well. God bless you. If you're traveling, have a safe travel. Safe travels. And we are out of here. So I'm going to cut off the recording here at this point. And that's it. Good night and good luck.